All right, I'm going to go ahead and start. Hopefully, everybody's on that wants to join this afternoon. I'd first off like to say thank you all for taking the time to register and join this meeting. This is the second of two corn and soybean production meetings that we're having this spring. Um, I guess just to kind of start off, I'm Michael Plumblee. For those of you that don't know me, I'm the corn and soybean extension specialist here at Clemson. Again, this is the agenda for today. I'm not going to read through it, but we have, I think, a good program. We had a pretty successful meeting last week in terms of the information exchange that we received here today. So this will be the order that we're going to go in. I'm going to start off. I wanted to give y'all a little bit of a review for 2020 as it relates to South Carolina. So in 2020, we planted about 400,000 acres of corn in the state, and our average yield was 132 bushels per acre, which was one of the highest state averages that we've had over the last 20 years, or really forever. Our current corn price, I heard the report today, closed at 5.54 a bushel. So price is definitely up, which is good for this year. We'll see if it stays up. Hopefully it will. As far as soybean acreage, and last year we planted about 310,000 acres of soybeans, and our state yield again was 35 bushel. And soybean price as of now has made a significant jump over the last few, I guess, weeks or months in terms of what we're getting at the bin. So with that being said, I anticipate probably our corn and soybean acreage to increase in the state some. We kind of are split between cotton, soybeans, and corn, a third, and a third. But again, depending on what happens with fertilizer prices, corn may not go up quite as high as it would have. Again, but we're competing with soybean acres with $14 per bushel soybeans. So again, I think both commodities will increase some compared to the past few years. So again, I just wanted to give you a snapshot of what we're looking at in terms of our state production, corn planted acres and price. So this is graphed over the last 20 years. The green line up here is how many planted acres we've had in South Carolina, and the blue line is price. So again, you can see when corn prices got real high in 2012, and this red star is indicative of what our corn price is now. So you can see a little uptick there. Again, you don't really see any kind of trend in terms of corn acres and price, at least in the state. Whereas when price went up really high, we didn't see a huge spike in planted acres. So I would imagine that our planted acres will probably stay pretty level, at least at this point. Not quite the same with soybeans. We've seen kind of a decline in soybean acreage over the last few years. But again, I think that's because we've had sub $10 bushel beans for the last 4 or 5 years. So again, red star is showing where our soybean price is as of now. So with that price increase and the increase that we've seen in fertilizer over the last few weeks, I would anticipate our acreage to probably tick up a little bit. In terms of our yield in the state, again, I mentioned that our corn yield and soybean yields last year were pretty good. Looking at several historical yields for the state, a lot of our acreage is dry land, so a lot of it depends on rainfall that we do get. Again, we had pretty timely rainfall last year, and I hope we have the same again this year. But you can see the green line being corn, the blue line being soybeans. We're definitely on an upward trend in terms of yield in the state for corn, and we are trending upwards in soybeans as well, but not quite as sharp as corn has over the last 20 years. So a few updates for this year, some things to be aware of and be on the lookout for throughout the growing season. We are updating our soybean production guide this year. We hope to have that available online in mid-March, so be on the lookout for that. We should have some new information in there and some updated information that will help you hopefully make some decisions for the 2021 growing season. We are planning on updating our corn production guide for next year for 2022. So again, next year we'll have it out in time for you to make decisions before planting corn. So keep that in the back of your mind as well, that'll be in print next year. As of now, all of our 2020 OVT data for corn and soybeans is available online at this website. So again, we do official variety trials at a few different locations across the state. These are small plot locations. Several different hybrids and varieties are entered every year in replicated studies. So if you're still making decisions on what hybrids or varieties you're going to select for your farm, I would highly recommend you look at the OVT data to maybe help make some of your decisions on what you're going to plant this year. And the last thing is we also have updated enterprise budgets available at that link on the agribusiness website. So if you're still playing with budgets, especially with these fertilizer prices increasing and commodity prices as well, and trying to decide acreages and what commodities you are going to plant, again, I encourage you to maybe take those a look. And they've just been updated, so all the prices in them should be current for both corn and soybean. Something else that's new for this year, 2021, we're starting county level hybrid demonstrations again. This is something that I'll kind of be overseeing across the state. As of now, we've committed to doing 8 locations, 4 of those being irrigated and 4 being non-irrigated. 7 of the 8 locations will be held in the coastal plain where the majority of our corn acres are, and 1 location will be in the southern Piedmont. And so as of now, we've kind of capped each location as having around 14 or 15 entries, but these are some of, or most of, the different hybrids that will be entered at each location. So not all of these hybrids will be seen at each location. We gave the companies a little bit of flexibility on what hybrids they wanted to enter, whether it was an irrigated or non-irrigated location. But these are some of the numbers. So I don't know if these are some hybrids that you've been looking at for this year or some that you've planted in the past. But hopefully at the conclusion of this trial this year, we ought to have a short list of hybrids that we recommend by location, production practice, and then whether or not it's irrigated for you to help make decisions for next year in terms of hybrid selection. So again, not going to read through all those, but like I said, if you want to take a picture of that or write a few down, these are some of the ones that we'll be seeing this year. So for the rest of, I guess, my allotted time today for the update, I just wanted to kind of get the ball rolling and a few things to say to kind of get you thinking as we get ready to start planting corn and soybeans. So I don't know how much y'all keep up with some of the planter technology groups like Precision Planting and some of the high-speed precision technologies. A lot of focus has recently been placed on planter setup, planter maintenance, and then adding technologies to help with uniform emergence in plant stands, especially in corn. And we've evaluated some of these at Clemson over the last couple of years, specifically in soybeans and cotton. And so I'm going to share a little bit of that data with you today on soybeans. But ultimately, what we're trying to do with some of these technologies and making sure that our planters are set up adequately is we want to have even emergence, especially with a crop like corn. And so what we've seen, or not specifically here, but other researchers have seen that yield in corn can vary 8 to 10% depending on how even your emergence is after we plant. So ways that we can affect how even our emergence is even plant or uniform planting depth. And so some of these technologies such as Downforce help us do a better job in ensuring that we have uniform seeding depth. So ideally, kind of our recommendation would be, in a perfect world, we have all of our corn plants in a field emerge within 12 to 24 hours. Again, this is all related to, we want all of our plants coming up out of the ground at the same time so that we're not crowding out other plants that come up delayed and reducing yield. And so some other things to consider, aside from the planter, when we're making decisions on when to plant and how to plant, especially things like corn, is soil temperature. And so, I go around with like a meat thermometer, stick it in the ground and look at our different soil temperatures at different depths prior to planting to hopefully make the best decision that I can. Again, germination, the cooler our soils are, the slower it's going to take to germinate. And we obviously want to get our seed in the ground and get it up out of the ground as quick as we can so we don't run into issues with cool, wet soil. So again, our recommendation now for soil temperature and planting corn would be 50 degrees Fahrenheit at a 4-inch depth or 55 degrees at a 2-inch soil depth. And something to consider with this is, kind of look at the forecast on temperature when we're getting ready to go out and plant. We obviously want decently warm temperatures after we put the seed in the ground to make sure we're collecting enough heat to start the germination process and again get those plants out of the ground. So some other things to consider for planting corn. Again, management of our inputs in corn at timely intervals is definitely going to be essential. And all of you are well aware, I'm sure, that corn is not one that takes stress very lightly. So there are ways that we can obviously alleviate stresses through the use of irrigation, supplemental water, but also ensuring that we have what we need out there at the right time, I think is going to be very important in hitting some of these higher corn yields. So again, we want to ensure that our inputs are there prior to needing them, whether it's water, fertilizer, or pesticides. And so something like with corn that's really heat dependent, we do have the ability to track plant growth through the heat unit accumulation or growing degree day units. I'm not sure how many of y'all use these to calculate the progress of your crop, but it is a very good tool to use year in and year out to track how far along our crop is based on actual temperatures from that year. And so again, understanding these plant development stages, especially in corn, I think is going to be essential for moving forward and managing our corn to the best of our ability. So I'm showing this slide and picture here. Again, Dr. Famaha will be talking a little bit later about some fertility related issues in corn and beans. But I think it kind of, puts it in perspective on what we're looking at. So again, this is percent of total uptake of the three main nutrients that we're applying to all of our crops: nitrogen, phosphorus, and potassium. And something that you'll notice is really when we start to get around this V6, V7 growth stage in corn, our uptake of all three of these nutrients really begin to increase and go on throughout tassel. So when we're applying fertilizer or coming back with a side dress, it's going to be essential to make sure that we're timely in getting our nitrogen, phosphorus, and potassium out there to the plant prior to the plant actually needing it. So again, if you remember, I said around that V6, V7 growth stage, our nutrient requirement really starts to increase. Well, if you look at what the corn growth and development timeline kind of looks at, again, you look at this V6 growth stage, a lot of different things are beginning to initiate in that corn plant. And again, that's why we're starting to see that big upswing with nutrients being used. So whether we're starting to initiate the tassel and growth or the ear, or how many kernels we're putting on a cob, again, we want to make sure that we don't stress that plant or starve it of nutrients at that time. So kind of shifting gears into soybeans, I'm going to talk with you a little bit about some of the research that I've conducted over the last 2 years with a graduate student. This work was funded by the South Carolina Soybean Board, the checkoff dollars, so we do appreciate them for helping us look at this and evaluate planter downforce technology in South Carolina and soybeans. So again, we did this trial 2 years. We had 2 different locations, one in the Piedmont of the state and one in the coastal plain. And then we evaluated active and static downforce rates. And so the difference between active and static downforce: active downforce responds to the changing in soil variation across the field. So we can set a different rate and the planter responds to that rate as we go across the field. Our static rate, we simply apply a rate and it doesn't matter what happens across the field or soil texture or soil compaction or anything that goes on across the field, the planter is going to still maintain that same rate. So in our active trial, we looked at 50 to 200 pounds and 50-pound increments. And then our static, we went from 0 pounds applied all the way up to 300 pounds applied in 50-pound increments. So kind of the quick and dirty summary of our research with this project was that we did influence emergence in soybean, depending on what downforce rate we used, but yield was not impacted by any of the downforce rates that we used. And so sometimes I like to say, no differences is sometimes just as good as having differences when we do a research project. And what I mean by that is if you are using downforce on your planter in soybean, you do have the ability to use a wide range of downforce rates without really having an adverse effect on yield. And so I think the goal or the main objective with a lot of this is we want to make sure that the planter is maintaining good contact with the ground, and we can get up to some higher end rates without really having a lot of sidewall compaction or seeing any yield decline. One thing that I get asked a lot about with some of these technologies, though, is what is my return on investment? And unfortunately with this, at least in soybean, if we didn't have any yield differences, we don't really see a return on investment necessarily in soybean with that type of technology. So that's something to consider if you're upgrading your planter or looking at some of these technologies specifically for that commodity. So real quick, I'm going to go through a few data slides just to kind of show you what we did see with this trial. So this is looking at 2019 results from the coastal plain. This is emergence counts taken 3 days after the first plant emerged. So I had a graduate student, you go out and count plants in 5 foot a row, the same 5 foot a row every day for 4 consecutive days after the first plant emerged. You can see here, even though we have some numerical differences, we had no statistical difference in downforce rate on emergence in the coastal plain. In 2020, a similar story, at least 4 days out, but early on we did have a little bit of a difference where our lower downforce rates in soybean last year in the coastal plain did have a few more plants emerged than our rates at 150 pounds and greater. A little bit different story at in the Piedmont up in the upstate where we have a lot more sandy clay loams and soil textures like that, where we increase our downforce rate over 150 pounds, we actually did see a little bit better emergence in 2019 and similarly in 2020. So again, this is 2 and 4 days after emergence with the different color bars, but we still saw a similar effect where over this 150 pounds, we actually did a little bit better on how many plants we got up out of the ground. So like I mentioned before, we looked at static and active downforce. So the first couple slides were static rates, but then looking at active, at least down here in 2019, we actually saw a little bit of a decline in emergence counts where we had 150 pounds of active downforce compared to some of our lower rates. We really weren't able to describe or say why we saw that decline in emergence last year, because this year, we didn't see any differences regardless of downforce rate and emergence counts in our active trials. So again, I think the moral of the story is some emergence counts were affected, but at the end of the day, soybean yield was not. So again, this is 2019 and 2020 data, looking at grain yield on soybean for our static downforce in the coastal plain. No significant differences regardless of soybean or regardless of downforce rate, and similarly with the active again in the coastal plain. So with that being said, I think we have a lot of technologies on the market that can help us do a lot better job. We're actively trying to evaluate how these technologies fit into our production practices and what makes sense to invest in. But know that, we obviously didn't hinder our yields using some of these technologies, but at the end of the day, we didn't see a huge yield benefit, at least among rates with some of these type things. So with that being said, I'm going to turn the program now over to our next speaker. I think I saw Francis on here. Francis, are you ready to?
Yes, I am. Yes.
All right. Well, whenever you're ready, I'm going to turn it over to you. And like I said before, if y'all have any questions that are coming to mind now, feel free to go ahead and put them in the chat. And we'll make sure that we get these answered at the conclusion of the update. So thank you.
All righty. Is that working, everyone? Can you see my slide?
Yeah, we can see it. You're good to go.
Good.
All right, it's working today. Wonderful. Well, I appreciate the opportunity to talk just for a few minutes about a couple of insect issues in corn. And I'm going to start off by talking about BT corn. A lot of you have probably ordered your seed and purchased your seed. And as you all know, there's a range of different BT traits available. And so they've been commercialized since '96. And they were initially developed for European corn borer control, right? And these were the single gene products. So they expressed one single toxin. And they're very effective for European corn borers. European corn borers used to be abundant here in South Carolina, but in the 15 years that I've been here, I've yet to see one. And so their populations have declined over time, in part because of the widespread use of BT corn. And so the products that you're buying now are expressing 2 or 3 toxins. And so this has expanded the range of insects that are suppressed or controlled by BT corn. These are traits for above ground pests. There are also BT traits for below ground pests, which are rootworms. Now, rootworms are major pests in the Midwest. Here in the Southeast, they're not pests unless you're planting corn after corn with no rotation. But we don't recommend using these products for rootworms since rotation is common here in most cases. You will note that there are very few BT toxins, and that these products that are available, like we call them pyramids, when there's expressing multiple toxins, they're basically different combinations of a small number of BT toxins. So the two most common pests that these BT traits are targeting here in South Carolina are fall armyworm and Cornea worm. And you'll note that for fall armyworm, these are the ratings here, E for excellent and VG for very good. We're fortunate that these pyramids are very good for armyworm in general. There's some resistance to the Cry1F gene here, but in general, they're excellent to very good. And as you know, armyworm is a sporadic pest. The risk from significant damage in corn increases the later you plant. Some folks do or have double crop corn, after wheat. And if you do that, that's a high risk situation for armyworm. These are insects which do not overwinter here in South Carolina. They migrate from the Caribbean, from South Florida every year. And so they tend to show up a little bit later during the growing season. And so we've all seen this typical, leaf feeding and whorl damage from armyworm and from a non-BT hybrid. And this was planted super late, 8th of July, which we don't recommend. But we did that to get this high armyworm pressure in this trial. And the BT trait here, there was no damage whatsoever. Now, I have seen on occasion fields planted within our recommended window that still had high armyworm pressure. And so they can sometimes show up earlier in the season, but it's less common. But BT traits are really effective for armyworm. And they're fairly hard to control with insecticides if you're going through the field over small corn, because those larvae get into that world where they're fairly protected from coming in contact with the insecticide. So BT traits are generally more effective. Now, Cornea worm, of course, our most common pest targeted by BT corn. And as you know, the moths lay eggs on the silk, and those young larvae will go down the silk channel. And a lot of the feeding will occur on the silk and on the tip of the ear where the kernels haven't been pollinated. And so we often don't see significant effects on yield. And we do trials every year where we do compare BT and non-BT hybrids, and we've only rarely seen impacts on yield from corn earworm feeding. Now, on occasion, they can go further down that ear and feed more on the developed kernels where we can see a yield loss, but it's really rare to see that. The problem with this insect is that it has developed resistance to several BT toxins, and here are just some insects that have also developed resistance. But for us here in South Carolina, that resistance is a major concern because the earworm feeds on corn, but it also feeds on other hosts in our landscapes. So we see a generation on wild hosts before moving on to corn, and corn is a preferred host in our landscapes. And after it's developed on corn, it can move on to other crops such as cotton and soybean. In cotton, the insect is known as the bollworm, of course, where it's a major economic pest. And we have been seeing more problems in recent years in BT varieties in cotton, in particular the 2-gene varieties, Bulgar2, Twin Link, and White Strike. And in some cases, we've seen increases in the use of insecticide because these bollworms have become more resistant to some of these BT toxins. We've seen fewer problems in the triple gene products, Bulgar3, Twin Link Plus, and White Strike 3. And all of these products can expressing this VIP3A toxin. And VIP is the only toxin that we have, which is really effective for this insect. It's also used in corn in Optimum Leptra from Pioneer and Triceptor from Bayer. So this is a toxin that's widely used in these triple gene products. And we're concerned because it's the only toxin we have that's effective. And with resistance widespread to some of these other cry proteins, we need to preserve this technology because we're years away from any new trait in BT corn and BT cotton. So this is all we have basically for the next number of years. And just to show you the kind of resistance we've had in South Carolina, and this is true here and in other states in the Southeast and Southern US, we've seen decreases in efficacy in Double Pro, in Intrasec from Pioneer because of resistance. when Double Pro was first released, we typically saw 85 to 95% efficacy compared to a non-BT hybrid. But starting around 2014, we saw a drop in efficacy. And so in some fields, VT Double Pro may still look really good, but in other fields, it may look just as bad as a non-BT hybrid. So this is a major concern for us. So as you all know, the only thing we can do is plant non-BT refuge, which is required. And so it's really important to follow the guidelines for this. And so for these double or triple gene products in corn, the requirement is to plant 20% of the total acreage of corn on your farm with a non-BT refuge. And the goal of the refuge is to produce moths that are susceptible to these BT toxins that may then mate with any resistant survivors from the BT crop. And this will help to dilute these resistance genes in the populations of Cornea Worm. And so the non-BT refuge can be either planted in the strips in the field, in blocks, or within half a mile of the field. And so this resistance is really the greatest threat to the sustainability of using BT technology in corn and cotton. So I just want to emphasize the need to follow these guidelines, and because it is without BT technology in cotton, we would see, of course, an increase in the use of foliar insecticides, as it used to be. Now, I have a few slides to end my talk on stink bugs, because we had a few questions last time on stink bugs. They're probably the #1 economic pest in corn in South Carolina, and we have a complex of species. Brown marmoset is one of them, but we only see it so far that I've seen in low numbers. This is an invasive pest, which was first found in the northeastern US, and it slowly made its way down to South Carolina, and it's been here for a number of years now. We see more of it in the upstate, in particular around homes in the fall. Also on peach trees, for instance, it's a major pest. We have seen it here in the PD area and in other in the coastal plain, in cotton and soybean, and a few in corn, but it's not nearly as common as our the main species, the brown stink bug, which looks fairly similar. Now, for all stink bug species, whether it be the brown marmoset, the brown, the southern green, or green, we recommend using bifenthrin. It's the most effective among pyrethroids for stink bugs. And so we recently modified our thresholds, because there's research, in particular from North Carolina, which suggests that we do need to be slightly more aggressive when making decisions for stink bugs in corn. Now, they're really hard to scout because they're highly mobile. And as you walk through the fields, as you know, if you've looked for them, they sort of try to hide on the other side of stems and under leaves. And so we have a 10% threshold for the seedling stage. When feeding occurs at the seedling stage, it can lead to complete loss of that plant, right? If the plant becomes malformed. As the plant gets older, it becomes slightly more tolerant. When that ear is elongating and the V12 to VT, when it's growing inside the stem, the stink bugs are really good at finding that location on the stem and feeding on that developing ear. And that's when we see that typical banana-shaped ear. So we have a 25% threshold at that growth stage. And then once the ear comes out and the kernels are developing, when the stink bug is feeding, you're basically losing one kernel at a time. So we only have a 50% threshold at that time. Now, when can stink bugs be a problem, or where can they be more of a problem? Often in cornfields planted in no-till with a heavy cover, that can be a situation where we can sometimes see greater stink bug pressure. At the interface between wheat and corn, we can see also more problems there. We know that stink bugs love corn, and when that corn matures or is harvested, sometimes stink bugs can move to adjacent vegetation. And if it's corn, we can see problems along that interface, but it's not a guarantee. Stink bugs love soybean, and later in the season, once that crop matures and is harvested, they're moving to overwintering sites. And if you're coming back and planting corn in that field the following year where soybean was, it's possible that could be a high-risk situation because there's a greater number of stink bugs in that area. So that's my last slide, and I guess questions now or later, depending on the time, and I will stop sharing my screen right now. There you go.
Yeah, so thank you, Francis, for that update. If y'all have a question, definitely drop it in the chat. Otherwise, I think we're going to keep moving along, if that's okay. If Jeremy's ready, Dr. Jeremy Green will be our next speaker, talking a little bit about entomology and soybeans.
Yeah, I'm here. Let me share my screen. All right, can you guys see that? You got the full screen now?
Yep, we're good.
Okay.
Thank you.
All right, let's talk a little bit about insects that are problematic in soybeans. Francis did a great job on the corn insects, and a lot of the insects that we have problems with in corn are also issues in soybeans. So most of the problematic species can be classified in three major categories: stem feeders, defoliators, and pod feeders. And I don't have a lot of slides today. I didn't bring charts. I was hopeful, just like our first session, for some discussion on managing insects in soybeans. Just going to show you some slides with some pictures of insects and talk briefly about the thresholds and some of our observations from last year. But stem feeders, kudzu bugs, we got hoppers, we have borers inside the stems. Defoliators, lots of insects like to eat the leaves of soybeans, and then we'll kind of end with pod feeders, stink bugs, and primarily podworm. And all these insects don't occur season long, right? Some of them are problematic during a specific window. For example, podworm, stink bugs, they're after the pods, they're after the seeds. So you're not going to see them in great numbers before that. And then the other insects that are interested in the leaves can show up a little earlier. So we usually deal with these things in a complex at a time, but they occur usually in one particular part of the season. So that's helpful. So one of the insects that I think we're missing a lot early is the three-cornered alfalfa hopper. And we're all guilty of it. We all wait until the soybeans are pretty much the canopy is made and closing, and then we start noticing holes in the leaves, and then we go manage insects. But this is one that I think is, it's a stem feeder. This is one that I think is probably hurting us early, and we need to look at some vegetative stage soybeans to kind of get a handle on it. So they girdle the stems. They kind of go around the trunk, if you will, like a squirrel goes around the trunk of a tree, and they girdle it with their piercing, sucking mouth parts, and it creates a weakened point there, and the plants can lodge before the combine goes to the field. So we have thresholds. They really have to be pretty thick, several per row foot or several per sweep. And the pyrethroid insecticides are very effective on this species, but this is one, again, I think maybe hurting us early in certain fields. If you have a late burn down, if you're burned down before planting is really, really close to planting, and then you have some plants emerge and insects move off of that drying vegetation that you burn down onto the soybean seedlings, you can have some issues with insects like hoppers. So I think we just need to be looking and sweeping some of our vegetative stage soybeans to look for hoppers. Kudzu bug, this is one that was not in the United States before 2009. By May of 2011, every county in South Carolina was infested with this species. So it rapidly colonized the Southeast. 2 generations per year that we deal with, and we did a lot of work on this insect, developed thresholds for it based on the immature stage and breaking that life cycle, and found out a lot of things about this insect. The pyrethroids are very good at controlling it. And then they kind of disappeared for several years, and we suspect that some of the natural controls may have been heavily regulating this insect species. And those are parasitoids. There's actually a nematode that attacks kudzu bug. And then there's a fungal organism that's perhaps the best natural control of Bavaria bassiana. This fungal organism can really hurt numbers of kudzu bugs. So we think maybe that's what happened several years ago, but in the last 2 or 3 years, kudzu bugs seem to have rebounded. There's probably some environmental interaction going on there as well, where the environment just favors their reproduction and success. So anyhow, they're kind of back. For the last couple of years, they've been the most numerous species in untreated plots of soybeans that I have Had my crew sample repeatedly, and they can just get to horrendous numbers if you don't control them, but they're thankfully very susceptible to the pyrethroids, specifically bifenthrin, which is the one that Dr. Ray Jones mentioned for good stink bug control in corn. So anyhow, something to deal with, not hard to control, but kudzu bugs are out there and can be quite numerous. Grasshoppers, we've received a lot more calls about grasshoppers over the years. And it's basically boils down to how this insect reproduces. It puts egg pods in the soil, and we don't disc, we don't till like we used to, or minimum tillage, strip tillage, and we pretty much leave a lot of these egg pods intact, and we're not mechanically destroying them like we used to. So in fields with minimum tillage and where you've got a lot of residue, perhaps a burn down that was too close to planting, you can have issues with grasshoppers, threatening the stand by chewing down entire plants. But usually they're a defoliating pest and feed on the leaves. When they get big and have wings, they're very difficult to control. So you want to get them when they're in the immature stage, where they're more susceptible to insecticides. You can look at stand and make sure you're protecting the stand early, but then after that, we kind of fall into this 30% defoliation threshold before bloom, and then 15% after that. Pyrethroids are, you can control them with pyrethroids and organophosphate insecticides, but again, once they get to be large winged adults, they're very difficult to control. Dimilin is an insect growth regulator. That's another option. Fairly inexpensive, long residual, probably something folks need to consider if they're dealing with the history of grasshoppers in certain fields. Stink bugs, a lot of the same species that feed on corn and cotton and other crops are also problematic in soybeans, but stink bugs really love soybeans. I hope you can see my arrow, but right here, this particular species, and these are a lot of pictures of immatures because they're often the ones that are difficult to identify. This is the red banded stink bug. It's very reproductively capable, a lot like the southern green stink bug, but it's a little more difficult to control. You need to use something like a bifenthrin plus orthene acephate to control this species. It's the #1 pest species of soybeans in states like Louisiana. They've had some very cold temperatures here lately, and this species is very susceptible to cold temperatures, so it's probably going to be knocked back in that geography. We've had quite a few of them here in the last couple of years. Hasn't got cold here yet. I don't anticipate us having a good kill unless it turns off cold between now and late spring and summer. But multiple species out there. Brown stink bug is also another one that's difficult to control. You need to use something like bifenthrin specifically with the pyrethroids because it has good activity, or acephate, an OP. 1 bug per row foot, or 1 to 2 per 10 sweeps will be the threshold for stink bugs. Green cloverworm, we have a lot of species of caterpillars that are migratory. Dr. Ray Jones mentioned that for fall armyworm, and a lot of the species we have in soybeans are migratory, which means they don't successfully overwinter here to any large degree. They move in from southern geographies, but green cloverworm is usually not one that gives us a problem by itself as a defoliating pest. It's usually part of a complex that includes soybean looper and BBC. But again, 30% defoliation before mid-bloom, and then 15% thereafter, where we can stand a little less foliage loss. It's very susceptible to insecticides. I like to point out it's one of the moths that has this forward projecting snout, so you can actually get a heads up on what's coming if you can identify large populations of this moth flying around, and we'll talk about that with some of the other species. 3 pairs of abdominal prolegs here in the middle of the caterpillar. VBC, velvet bean caterpillar, another migratory pest, usually more problematic in southern South Carolina, but we can see it push up into other places. In the last couple of years, been a very abundant species down here, at least in the southern part of the state. And in 2019, we had populations migrating into the state that were tolerant of a lot of different insecticides. It was kind of scary. Collection was made out of a field that was sprayed twice with the good rate of a pyrethroid, and then we did some bioassays in the lab and confirmed that they were tolerant to or resistant to a lot of different chemicals. So a voracious insect. It snuck up on somebody within a week, and then they tried to control it and couldn't do it. Thankfully, last year in 2020, we didn't see those resistant populations. They were pretty much susceptible to whatever we threw at them last year, and that's a good thing. I would hate to have seen that happen in repetitive years. The moth of this species has wings that are kind of out to the sides at rest, so it's very distinct, and you definitely need to be able to identify this adult, so you don't see this kind of defoliation. 4 sets of abdominal prolegs for this species. Soybean looper, another mostly migratory species, the defoliator. This one's difficult to control with insecticides. The pyrethroids won't work. You got to use some of these LEP-specific chemistries like Prevathon or Intrepid Edge, or mixtures that include chlorantraniliprole like Besiege, things like that to control this insect. White spots on the forewings of the moths, 2 sets of abdominal prolegs, the true legs, sometimes black, sometimes green. So need to be able to identify these species. And I failed to point out with green cloverworm that very small green cloverworms actually crawl and loop like soybean looper. So you want to be able to count these sets of abdominal prolegs and identify these species, because you don't want to apply a very expensive insecticide thinking you've got soybean looper when you basically have green cloverworm. So be able to identify these moths and the caterpillars, and you kind of be ahead of the game. Podworm in soybeans, we call it cornea worm in corn, we call it bollworm in cotton, same species, an important species that's a seed feeder. Again, I hope you can see my cursor, but you can see where they have fed through the side of the pods here and destroyed some of the seeds, even eating the whole entire pod. So aptly named it podworm. 2 per row foot on 38-inch rows, or several per 10 sweeps. There's a closely related species, the tobacco budworm, that can be, that looks the same in the larval stage, differs in the adult stage, but we can have populations of tobacco budworm in soybeans that are clearly resistant to pyrethroid insecticides, which used to be something that we really needed to be able to tell these guys apart in soybeans. It's becoming less and less of a problem because the pyrethroids are becoming less effective on podworm, bollworm, cornea worm, whatever you want to call it. And quickly, I'll just go through this. This basically just shows you a laboratory bioassay where we're checking survivorship in a vial test with the adults, and we were pretty good moving along until 2016, and we noticed at a discriminating dose for cypermethrin, a pyrethroid used for years and years in this sort of assay, we noticed increased survivorship in 2016, and it's been elevated since then, but it hasn't been as high. So this basically tells us the pyrethroids don't work as well as they used to on podworm, cornea worm, bollworm, but they still give us some control, but not as good as they used to be. All right, so proper identification, I talked about that, being able to count these prolegs, abdominal prolegs, being able to identify these moths, it's all critical. Make sure you can do that. And then some of the threshold information is here. It's also in our pest management handbook, which is out. Dr. Marshall has got that out quickly this year, so make sure you pick up a copy of that. Thresholds by sweep net and drop cloth are included in the soybean insect section in that handbook. And quickly, I'll just mention BT Soybean Research. We've been looking at BT soybeans here in my program for a number of years. Very good product. Expression of the cryoproteins is very high in soybeans, so it provides very good control of a lot of the caterpillar insects. Not commercially available here in the United States. It's being sold commercially in South America and has been since 2013 with some success down there, but they're also seeing some emerging issues with resistance. So if that's going to be available here or not, it kind of plays into the discussion that we have in academia about another BT crop and another source of pressure on these BT toxins. So that'll be it. Michael, I can take any questions now or can wait till the end.
Okay, thank you, Dr. Green. I think we're just going to keep moving along. Like I said, if y'all have any questions, you can direct message them to Hannah or myself, and we'll make sure that they get that get answered here at the conclusion of the update. So our next speaker this afternoon will be Dr. Mike Marshall, our weed scientist at Clemson. So Mike, I don't know, are you on or ready?
Yeah, I'm ready. Sorry.
No, you're good.
just a second.
Hey, and sorry, I didn't turn on my camera. I am here. Bye.
All right. You see it?
Yep, looks good. Thank you.
Yeah.
All right. Thank you. All right. Well, thanks for having me here today. Here to talk about the corn and soybean weed update for 2021. There's been I wanted to put some I guess some herbicides you may or may not have heard of or thinking about in your corn herbicide program. Atrazine's been a very popular, very cheap herbicide in our corn weed management programs over the years. And, there's been some, atrazine is always kind of has got the bullseye target on it by the environmental groups, because of its high water solubility and leaching potential and all kinds of other stuff that it kind of has a negative environmental profile. But so far we've been able to keep it. But the last article, it's currently in a re-registration review under the Endangered Species Act. And anyway, the rumor floating around is that they might cut the rates back even more than they already have. So just keep that in the back of your mind that we might have a time when we be limited to a pint per season, or some quantity that's not going to give us very much weed control. So in our in the corn market, if companies are developing a new herbicide, they always go for the corn market because that's the largest market in the United States, and that's where all the money is, compared to other crops. Corn and soybeans are number one. Typically product development and mode of action development, it targets that first, and then it kind of ripples down from there. So the HPPD chemistry, I don't know if you're familiar with that. That's not a new one. It was developed in the 80s. That was kind of one of the last times we had a new mode of action developed. So, the corn has several premixes that have, of course, have a lot of atrazine. These herbicide names that I have, these are common names, obviously, but the trade names are up here, like Acuron, Harness, Max, Lumex, etc. And I got them broken down by pre and post emergent timings. And one of the newer ones that has come onto the market in recent year, in the last couple of years, is Acuron from Syngenta, and it's got four herbicide products, active ingredients in it. So these, the point I'm trying to make here is that there is atrazine resistance in some weeds out there in the southeast, and so we need to think about diversifying our corn herbicide programs. And a lot of these programs that are listed here are either one pass type, pre-emergent one pass program or two pass program. So just depends on the herbicide you're talking about here. So anyway, I just want to bring that to your attention. That of course the more modes of action we have in here, like I'll just pick on one here, like Halix GT. We got three. We got a group 15 dual, glyphosate 9, and mesotrione is a group 27. Some of them, like Impact Z, are good on this Caprino and Impact Z are very good on some of our grass species that we have in corn, like Texas Panicum, if we don't have Roundup in the tank, for example. So, and they provide some residual, like the carbazone and topramezone have some residual grass activity. So, anyway, so just make you aware of that. In the pest management handbook, there are more. These are the kind of a majority of the ones I thought were, should make you aware of. But the pest management handbook has a lot more details about all these herbicides. Shifting gears, I wanted to mention to you about some herbicides in corn. We have what we call a interaction with insecticides, and both soil applied and foliar applied. And a lot of them, all of them are in the what we call the ALS inhibitor family, or they contain an ALS inhibitor. Like this Caprino I mentioned has thiocarbazone, which is an ALS mode of action 2 herbicide. So most of them have this ALS inhibitor component, and this is what interacts with the insecticide or nematicide in the case, counter versus like Lorazban, etc. So, depending on the label, we can put these products in the seed. We can put it T-banded. We can put it to the side of the row, etc. There's different use patterns. We can band it. So depending on the label, it does tell you do not apply. If, for example, if these guys are put in, this counter, etc. products are put in the seed, do not apply Accent and Beacon, for example. In terms of if we go down the list here for the in-furrow or soil applied products, some of them are no uses at all. Some allow, like the Accent Beacon, allow banded or T applied, etc. So just consult your label. They have it on here, and it's this is information is all in the pest management handbook too, that you can follow, that you can look up. Some give a waiting period between the application of the in-furrow and or soil applied insecticide, like Realm Q and Revulin Q. It's 45 days. So that kind of puts you, realistically, that puts you at kind of the window outside of corn post-emergent application, 45 days. So anyway, all this information is on the label just to make you aware of it. In terms of our foliar OPs and carbamates, they have these herbicides have these various either do not tank mix at all, or they have some sort of you apply it and wait, either apply the insecticide and wait 7 days to apply the herbicide, or etc. So depending on the herbicide here, we have some that just wait an interval of 7 or 10 days, or wait 7 days before, 3 days after, etc. And some, the Accent and Steadfast, are do not tank mix. So really, this is all has to do with when these insecticides get inside the plant has to break them down, and when we add the herbicide on top of that, reduces the ability of the corn plant to break down what normally the plant is tolerant of, because it can metabolize it, but with its metabolizing something else, it can't metabolize the herbicide, so you get some injury. So I think, let's see. Oh. All right. So this is a, kind of a reaction to some injury that we saw in a farmer's field last year, and this was a post-emergent application of Realm Q, and there was no soil applied insecticide in this case. They did apply Warrior, which is fine, but really what happened here was it was cool and wet during the period following the Realm Q application. And I just want to show you some symptoms of where the plant kind of stopped growing for a period, and you have kind of an internode stacking or twisting, and then it'll continue to grow above it. So you'll kind of have these misshapen, or the leaves will not unfurl properly. So it just slows down that. Corn is kind of like it's got to have these check boxes tick off during its growth stages, and if it's delayed in any part of that, it just has a hard time recovering from that. So a lot of this was environmental, but I just want to show you a kind of a flavor of what this internode stacking you would see with the insecticide herbicide interaction. Moving on to kind of the harvest aids and post-harvest options in corn. We talk about, morning glory is the question I get, a lot in corn, and unfortunately I don't have a soil residual answer for guys. They want to put something out at 6 to 8 leaf corn and get them through to harvest with a residual, but they don't make that product, mainly because companies be worried about carryover effects. So as morning glory is a weed that germinates all season up till frost. You can find morning glories coming up. So that's the challenge we have. And as that corn plant starts to mature and the leaves start to droop and senesce, light is able to reach the ground layer, and then the morning glory starts to take over, starts to germinate, and it can grow very fast. It's a very fast growing weed, especially when it's warm and there's moisture, and there's a nice tall plant to grow up on right next to it. So the options, these are from the recommended options. 2,4-D is the earliest you can spray. This is about 40 days after silking. The other 3, AIM, Roundup, and Paraquat, are all after black layer. So if you have the capability and you're not near any sensitive crops like cotton or tobacco or whatever, any kind of sensitive crop, you can run a sprayer over the top of it with drops, potentially. I know that's not a lot of guys have that capability here with high spray, tall sprayers with drops, but that's what they recommend on the label is use drops. AIM is one that's often used, sprayed by airplane to desiccate morning glories. Paraquat, I think Parazone is the only one I know of that has a label for post-harvest or pre-harvest application in corn. But it's similar to that. Glyphosate, that's not going to have a lot of activity on large morning glory, so it's not a morning glory herbicide, but it could be other weeds out there. You can tank mix with one of these products to control other weeds that say sickle pod or something that you want to prevent seed production, because that's really what the goal of pre-harvest is to desiccate and try to minimize seed production. Because looking at post-harvest, we harvest corn July and August, and we have up to 3 months more of growing season after that for weeds. And so thinking about something to apply especially after harvest, at least Paraquat is a good option on just to minimize seed production. Because if you're talking about glyphosate resistant palmer amaranth, that would not work on it, obviously, but or morning glory, but it would work on other weeds. Say you have some you've been in a strip till or minimum till for a while, and you're starting to get some perennial weeds out there like briars and etc., and you want to maybe work on those a little bit with glyphosate. That would be an option. So again, with the 2,4-D, just have to watch out for sensitive crops nearby. But there are some, I would have mentioned, other states have done research on putting out residual herbicides in the fall, in the late summer fall to minimize this fall weed seed rain, so to speak. And it just depends on your crop that you want to plant the next year. And I know a lot of guys are kind of they don't know what they're going to plant till way into the winter. They don't know it. So just put those out there. Lead off is one I can think of off the top of my head, but there are others that you can put out. Just depends on what you want to rotate to the following season. Okay, let me switch gears and move into soybean. Talk about the dicamba tolerant soybean. As you may or may not aware of, the XtendiMax, Tavian, and Ingenia were granted new labels last fall, and these are 5-year labels, so that's a good thing for us. We don't have such a short 2-year period, and then we have to go through this process again. So it's a 5-year label, and things that the thing I want to talk about today was right now the last day that you can apply any of these products on DT soybean is June 30th, regardless of when you plant. So for our late crop, double crop soybeans, that would most likely result in a scenario where you would not be able to use dicamba in the crop, because you'd be either at that date or past it by the time the soybeans and the weeds are at the right stage to spray. But I want to make you aware that we are applying for a supplemental 24 seed label for these 3 herbicides, and our goal here is to extend the cutoff date for application and dicamba application in this DT soybean to July 30th. So that should cover 95% of applications in DT soybean in South Carolina. So if you're planting soybeans past July 30th, that's kind of a risky thing. But like I said, the other thing I wanted to make you aware of is the XtendFlex soybeans. The Xtend soybeans were just dicamba and glyphosate tolerant. The XtendFlex soybeans, kind of like the XtendFlex cotton, they add Liberty tolerance to the soybeans. So these were approved in 2020. I believe that there are a number of seed varieties out there in soybeans. Mentioned that it added that Liberty tolerance. So check with your seeds, your Asgrow dealer. I think Pioneer's got some XtendFlex beans too. So just check with your seed supplier for that. But that gives us another option in our Xtend soybeans with Liberty. And I think the last thing here is just mention the Enlist soybeans E3. No changes were made to the Enlist Duo, which is the 2,4-D choline plus glyphosate, or the Enlist 1, which is 2,4-D choline by itself. That no changes were made in 2020 to 21 period in its use patterns, or just like obviously check read the label, there's a website on the Enlist crop Enlist 1 site to talk about the nozzles, and just like your dicamba, it has all the information in there, tank mixtures and stuff like that. But probably the biggest challenge for us is there's not many groups are available in this. There's 3 that I found on the Pioneer website. There's more. This is not the only 3 out there, but most of them are 4 or 5 or earlier. So just make you aware of that. There is 1.5. I grew this last year in my research trials, which is shown here. This 5.3, it did pretty good. Not a lot of trouble with harvest and stuff like that. So anyways, make you aware of that. With these, one last thing with the Enlist soybean, it's got Liberty tolerance too. So it's the 3-way 2,4-D, Liberty, and glyphosate. So I think with that, I think that's it. I think I can stop sharing and move on to the next speaker.
All right, thank you, Mike. So again, feel free to send any questions to the chat. We've had a fair number of direct message questions come in. So again, if you have any questions, feel free to send them our way. So our next speaker this afternoon will be Dr. John Mueller. We're going to talk a little bit about some disease issues and nematodes in corn and soybeans.
Oops, that didn't work.
No, you're good. Just go ahead and click your presentation mode down in the corner.
Where the world did it go? There we go.
Yeah,
Got it right?
Flip your screen up there at display settings, and you should be good. There you go.
All right. Thanks, Michael. Want to talk a little bit about corn and soybean disease issues for 2021. There's quite a few new things going on, and a few that have been bothering us for years. One of the biggest issues on corn, not just in South Carolina, but I think across the Southeast, has been the increasing observation of stubby root nematode, which is 10 years ago, we didn't think much about it, but it seems to be more and more common now. As I said, not just in South Carolina, but almost across the Southeast and even out into Texas. We're not really sure why it's increasing now. There's a lot of different theories, but the big thing is how are we going to deal with it? And we don't have a lot of answers right now. The first thing we need to do is avoid continuous corn if you can. If you have a field that has stubby root, and you can see to the left there how severe the stunting can be. And then the stubby root is actually just exactly what the name implies. The roots are really stubbed, look like a bottle brush, like the old, used to clean the old baby bottles with. We do have counter 20G at 6.5 pounds per acre. It's somewhat effective, maybe not as effective as we'd like it to be. It has a couple aspects that people don't like maybe. It comes in lock and load in the smart boxes, so you'll have to get set up to run those. And as Dr. Marshall just did an excellent job of explaining to you, you cannot use counter and the ALS herbicides. If you're going to use counter, you need to really get that story straight, get the labels, check in our pest management handbook, and probably talk to Mike about your herbicide options. So corn, we have other nematodes that are a problem, including root knot nematode, Columbia lance nematode, sting nematode, lesion nematode. As I said, these are getting more and more attention. There's seed treatments out there, Evicta Complete Corn. Most of these are commercially available. You can't apply them yourself anymore. But the Evicta Complete Corn, Poncho Votivo comes on a lot of the DeKalb products. And a fairly new product, Lumaios, hasn't been out long enough for me to learn how to pronounce it correctly. But this is a bacterium, bacillus, a specific strain that helps control nematodes. We do have some of the old-time nematicides, Telone at 3 gallons per acre, 3 gallons per acre. But unfortunately, this runs about $18 a gallon. And by the time you add in the price of applying this prior to planting, you're looking at more than $50 an acre. So you really need to be sure what kind of nematode problem you're dealing with and how much damage you have. Bayer was selling Propulse and promoting it, but they've kind of withdrawn that. They did go with a 2EE label to drop the rate down to 8 fluid ounces. The problem with this was it wasn't mixing well with some of the at-plant side dress fertilizers. So they've kind of backed away from that, and instead they're promoting Vellum, Fluparam, which you've seen on other crops. It was at 6.5 to 6.84, and just today they came out with a EE label that drops it down to 3 fluid ounces per acre. So we do have some options. when it comes to the nematicides. But first of all, get out and sample your fields. Be sure it's a nematode problem, and then we'll try and deal with it. The other big issue on corn are the foliar diseases. Everybody talks about should I or shouldn't I spray a fungicide for the different foliar diseases. 2 or 3 years ago, we had a lot of problem with what turned out to be Physoderma very early in the growing season. You can see the bands on the leaf. This is because the fungus was in the whorl with the leaves, which is very, very early in the growing season, well before tasseling. So you had to spray very early. We didn't really have anything to cope with this, but FMC has come out with Xyway, which is a fungicide that actually goes in furrow that they're promoting to apply in furrow to control both something like Physoderma early in the growing season, but also your later season diseases that are going to come out and appear after tasseling. You should note that if you're really worried about Physoderma and want to use this product, the rate for Physoderma is 11.8 fluid ounces per acre. If you use it to try and control diseases at tasseling, i.e. not Physoderma, you're looking at 5.8 fluid ounces. So there's quite a difference in rate there. When it comes to your foliar diseases on corn, you need to make up your mind. What have you seen in the past? What foliar diseases are you worried about? And what do you want to try and control? Because quite frankly, a lot of times you can control what you need by your variety selection. Northern corn leaf blight, if that's your concern, there are many varieties that have very, very strong resistance to northern corn leaf blight. Some of the others, gray leaf spot, southern corn leaf blight, not every variety is resistant. The common rust, southern rust, you need to get out the company ratings. They're fine. Get them out, identify what disease you're interested or diseases, and then go check one by one on each variety and make sure that the variety you buy has resistance to the diseases you're concerned with. I've found 28 different fungicides labeled on corn for foliar diseases. And I'm not about to try to show you all 28, but I did want to point out this. If you look in the column here where it says gray leaf spot, whoops, you'll see that it is very easily controlled by most of the fungicides. All of them get E's, or at least these top 10 got E's for excellent control. But if you start to move across, if your concern is northern corn leaf blight, you'll see that not every fungicide is providing excellent control. In fact, there was only one, the Priaxor, that gave excellent control. A lot of very goods, and Quadris wasn't quite as good as some of the others. Southern rust, which is one that gets a lot of attention a little bit later in the growing season, you can see that those reactions are a little bit more mixed. But if you think southern rust is the problem you might have, you need to look into some headline, Quiltic Cell, which is very good, Fortix, which is very good. So you really need to keep in mind what disease you're concerned about, what you think is going to develop, and then choose your variety accordingly, and then choose your fungicide accordingly. So switching over to soybean issues, we're going to talk about, once again, foliar diseases, and then, of course, I have to talk about nematodes. And my favorite nematode, Columbia lance nematode. The biggest thing on nematodes is we need to have a long-term plan. You can't just go out 1 year. You're never going to eliminate nematodes. We talk about nematode management. We don't talk about eliminating nematodes from any fields. It's just not going to happen. The picture on the left I've always found interesting. This is actually from some of my co-workers in Arkansas. This field had been in cotton for 5 years, and they really didn't see a lot of damage, but it turned out it was full of root knot nematode. And you can see with the year, they finally, in the 6th year, they planted soybeans, and look at the damage that occurred. Soybeans are much more susceptible to this kind of damage from root knot nematode than cotton is. And I really like this because it shows you they're not uniformly distributed. They can be spread in different pockets. There are probably different types, soil textures underneath the really bad pockets. But it shows you how much damage you can get in a field before you really know what's happening in the terms of the cotton, and that this is not uniformly spread across the field. And later on, we'll talk a little bit about developing plans. If you want to use some of the higher priced nematicides like Telone, there's areas of that field that obviously need to be treated. And then there's areas like the upper right-hand corner or the far left side that you could probably avoid using the Telone and put out something a lot less expensive. And you don't need a lot of expensive measurements to decide where your management zones need to be. We'll talk about that a little bit later. But after rotation, if you know what nematodes you have, we do have resistant varieties, especially to soybean cyst, root knot, and reniform in soybean. But you got to know exactly what species you have, because resistance to one species of nematode does not confer resistance to another species. Cotton is probably our most common rotation crop with soybeans, perhaps. But cotton is host to all the same nematodes as soybeans, with the exception of soybean cyst nematode, which will not go to cotton. However, this year we're going to talk, or you're going to hear a lot about, we have a new, what I call the second generation of root knot resistant cotton varieties. They're very, very effective in reducing reproduction by root knot nematode. They'll knock down the numbers almost 90% compared to a susceptible variety at the end of the year. And you can almost use these new resistant root knot nematode resistant cotton varieties as a rotation crop to take down your southern root knot nematode numbers. Root knot, we're seeing more and more of this. We're very conscious that there may be what they call Meloidogyne enterolobii. It's a new species. A lot of people call it sweet potato root knot nematode. The official common name is guava root knot nematode. I think the sweet potato name is better known in this area. But we're seeing these huge galls. In some cases, they turn out to be peanut root knot nematode. However, this race of peanut root knot nematode doesn't even go to peanut. But it does cause huge galls and a lot of damage on soybean. So if you see this kind of damage, please give us a call. We'll help you sort out what you really have and whether you can use a resistant variety or not in the future. But anytime you grow 2 years in a row or more of soybean, you're almost always going to have some sort of nematode problem develop. Only peanut, possibly sorghum, will reduce root knot nematode populations. There are a lot of resistant varieties for southern root knot nematode. We need to be sure that that's the species that you have. And in some cases, you'll need to use those resistant varieties and then put an additional nematicide on if you have really high levels of root knot, if you can't rotate around this. Soybean cyst nematode gets the most attention nationwide because it's so common in the upper Midwest. But quite frankly, we don't have a lot of it here because we grow corn, we grow cotton in rotation with soybeans. Neither is a host for soybean cyst nematode. So if we can grow soybeans only every second, maybe every third or fourth year, we're going to keep our cyst nematode populations down. There are many, many resistant varieties to soybean cyst nematode. You need to check and be sure, though. There are some that aren't. Be sure you're buying a resistant variety. There are multiple races. You need to keep an eye open for that, especially if you're going to grow more than 2 years in a row of soybean. You're going to have to be conscious of this race issue and give us a call and we'll walk you through that one. They can be minimized by rotations, and most of the nematicides affect all the races evenly. Reniform nematode, this is primarily from Orangeburg North, especially in Lee County and up on the North Carolina border. They have a lot of reniform nematode. This is a very prolific nematode. If you see 100 root knot or 100 Columbia lance nematodes, that's above threshold. And that's a lot. We rarely see more than 250 of either of those. Reniform nematode we see in numbers like 5,000 and 10,000. So it's very prolific, but fortunately, the damage it causes is not proportional to the number of nematodes that you see relevant to, say, cyst or root knot. It's takes a lot of Reniform nematodes to cause damage. There are some resistant varieties, but you're probably going to even have to ask the companies about whether or not they have a Reniform nematode resistant variety. Remember, resistance to one nematode species does not confer resistance to another. You buy a root knot nematode resistant variety, it's not going to do anything for your Reniform nematodes. If you're growing soybean and cotton in rotation, Reniform nematode builds to incredible levels on cotton. You're going to have a problem. That's all there is to it. And sometimes these numbers get so high, corn will knock it down, sorghum will knock it down, but you're going to probably have to plant that for 2 years to get these numbers down to where you can grow cotton or soybean again. Columbia lance nematode, this is about 1/3 of our fields in South Carolina, especially in the coastal plain. It's very hard to control. We have no resistance. So resistance to soybean cyst nematode, resistance to root knot nematode aren't going to do anything to Columbia lance nematode. The only crop that we grow that's not a host for Columbia lance nematode is peanut. And a lot of people, for good reason, don't like to grow soybeans and peanuts in rotation because of all the fungal diseases, the soil-borne fungal diseases like CBR and white mold that build up on soybean and then really give you a problem on peanut. So if you have Columbia lance, lesion, or stubby root nematodes, there's a good chance you're going to need a nematicide. And the choice of the nematicide may depend on, well, definitely depends on the level of damage you've seen and the soil texture that you have in that field. This is a drone photograph, and it's easy to see in this field where they have problems. Telone's extremely effective, but as we mentioned earlier, it's going to cost more than $50 an acre. Most soybean fields, we can't justify that kind of cost. But what we could do is go in, and once again, you can see the far left corner, the bottom left corner, we wouldn't have to treat there. Maybe that area in the very center, you don't have to treat. So this is something you might keep in mind. A lot of cotton growers in Southwest Georgia are starting to do this, and it's very effective. You can use yield maps to determine where you want to put out your telone. You don't have to invest a fortune in a lot of fancy mapping. The soybean seed treatments, right away I want to point out, if you look at the ones that have the cruiser on them, the thiamethoxam, you don't need to pay extra for this. I talked with Dr. Green quite a bit today about it. We don't have a big thrips problem on soybean in South Carolina. So instead of the Avicta Complete beans, you can buy one of the others. You could buy Cleriva PN rather than the Cleriva Elite beans because you don't need that thiamethoxam. All these seed treatments, though, I would tell you, are not as effective as the in-furrow materials. If you're going to try and rely on seed treatments, you need to know what level of nematodes you have in your field because it needs to be toward the light end of pressure. Otherwise, these will not provide enough control. There's a new seed treatment out, Saltro. You'll probably see ads from this. It's a new product from Syngenta. The real target for this is the sudden death syndrome soybean cyst nematode complex that they see a lot of in the Midwest. We don't tend to see a lot of SDS in South Carolina. We don't tend to have a lot of soybean cyst nematode in South Carolina, but if you've had that in a field and you're convinced that's your problem, then this may be something you want to try. Like vellum, Saltro is actually a fungicide, a fairly new one. The fungicide is one of the active ingredients in Moravis Top, which is a fungicide that's fairly popular right now. So Saltro's there, but really you need to know what you're dealing with. Target sudden death syndrome, fields with sudden death syndrome and with soybean cyst nematode is where this needs to be used. The old standby is AgLogic 15GG. The second G stands for gypsum now. That's about the only, there may be a little bit of the corn cob still left, but primarily it's being sold as gypsum. I think everybody knows how to apply this, 3 to 6 pounds per acre. If you were worried about thrips for some reason, it'll take care of that. We know that. The weakness of AgLogic is that the nematode numbers are going to bounce back. It gives you control for the first 30 to 40 days, which is enough to get a good yield increase, but you're going to see a significant increase in your nematode populations by the end of the year. And the next year you have to start over in terms of controlling the nematodes. One thing I want to remind you is, don't forget, if you want to buy AgLogic and use it, you need to complete their online stewardship training program and get the certificate so that you can buy the product. A little bit more here on foliar diseases of soybeans. I think when we talk about this, the first one that comes to mind is frog eye leaf spot. But quite frankly, if you'll go through the list of the varieties that are available in South Carolina, most of the 6s, 7s, and 8s have very good resistance to frog eye leaf spot. The reason you've heard so much about this is that in the Mid-South, they have populations of the fungus that are resistant to the fungicides. We haven't seen that develop here because we have good resistance. The fungal populations can't get started, can't build up. So we're not seeing a lot of trouble with frog eye leaf spot. The one that concerns me a lot first came out probably 6, 7 years ago, which is target spot. On the right, you can see a pretty good picture of what a lesion looks like. It looks exactly like an archery target with concentric rings and then a yellow halo around the outside. It doesn't take a lot of these. It produces a toxin that's going to cause the leaf to die, and you lose that photosynthetic area. There are varieties that are less susceptible. You can see to the left. On the far left is a susceptible variety. On the right is a partially resistant variety. There's a huge difference in the level of disease. Unfortunately, this disease, or fortunately, because we don't get a lot of cases of this, but unfortunately, by not having a lot out there, we don't get a chance to screen our varieties. And so we don't have a solid list of who's resistant and who's susceptible. If you see this, this is probably one of the opportunities I would say this would be a good time to spray a fungicide. Of course, the one that everybody was worried about is soybean rust. We first had this approximately 15 years ago now. On the right, Dr. Plumblee had some very late planted soybeans, and you can see to the spot where they turned the fungicide on and off. The green is where the fungicide was sprayed. The yellow, those leaves are just covered. That's a very late planted variety, but they're just covered with rust. Yields are going to be very poor there. We did have a test on the station. The rust came in very, very late, but we were able to show, if you look at this, there's a non-treated check at 49 bushels per acre. If you had 2 active ingredients in your fungicide, you got a little 2 bushel increase, but 3 active ingredients, we actually got a 7 bushel increase by controlling soybean rust. But we had to use a fungicide that had a very long residual period on it. If you have 1 active ingredient, you're probably going to get maybe 2 weeks of control. 2 active ingredients, maybe 3. Our 3 active ingredients gave us control past 3 weeks, which is why we were able to get this yield increase. There's 27 different fungicides labeled for soybeans. You might want to look at this. You might want to, most of them have some ratings for the diseases they do and don't control. But you might want to think about this. If you're going to spray earlier in the season, you want to use one of the 3 active ingredient fungicides probably. Now, naturally, these cost more than the others. So you need to make this a really conscientious decision that you're going to spend that money because you're going to think you need the fungicide for 3 to 4 weeks. That's what I have. Be happy to answer questions if anybody wants to put some in the chat room or anything comes up.
All right. Thank you very much. Our last speaker for today on the panel is Dr. Bhupinder Farmaha. So with that, I'm going to turn it over to Bhupinder, and then again, we'll have a short Q&A after the completion of this update. So if you have any questions, definitely send them through the chat. You're muted.
Okay, can you see my screen and can hear me?
Yep, you're good to go. Thank you.
Very good, thank you. Hi, my name is Bhupinder Farmaha, and I'll take 10 minutes to wrap up on corn and soybean fertility updates that can be useful going forward and as we are planning for 2021 growing season. So let's go to the basics first. Here on this slide, I am showing the comparison of the nitrogen, phosphorus, and potassium demands to grow 50 bushels of soybean in this column and 180 bushels of corn. So you can see that the nitrogen requirement is more or less similar to grow 50 bushel of soybean and 180 bushel of corn. So is true for the potassium also, 187 pound for the soybean and 180 pound for the corn. Though the phosphorus requirement for soybean is almost half to compare to the corn. So keep that in the mind that we do need to have a good fertility program to raise high yielding crops for both corn and beans. When we say that the soybean is a legume or a peanut is a legume and it fixes all the nitrogen, that is a myth, because legumes, they does fix the nitrogen, but most of the demand for these legumes is not met through the biological fixation. It picks quite a big chunk of the nitrogen from the soil itself. So that what I want to clear out also. Let's now move to the second slide. On this chart, this is a soybean chart and this is a corn one. First, we'll take a look on the soybean one, and these are the different colors representing what is the uptake of the potassium over time in different physiological organs of the soybean plant. So is for the corn. The blue one represent the potassium going into the grain. Red one or the maroon one is showing how much it remobilized to the flowers or the pods. Lighter green color shows which goes into the stems and petioles, and red later on remobilized to the harvesting organs. And at the last one, dark green, is what is going on to the leaves. So on the x-axis, there are two different kinds. One is the in terms of the days after planting, going from 0 to 120 days after planting. And that is the another one based on the growth stage, going from planting to R8 growth stage. Here is the percentage of the total K uptake from 0 to 100K. 100 means the total K uptake during the growing season. And here is the pounds of K taken up per acre by the plant or the removed. So giving you an example for case of soybean, when the plants are at the R2 growth stage, so the amount of the K uptake is about to 30%. Now, when we look at the R2 growth stage of the corn, the amount of the K uptake by corn is almost 80%. So it means that the corn is an early feeder for the K. So if you have a deficiency or the nutrition is not poor, you don't have much time to rectify that deficiency during the growing season, and you might lose a good chunk of the yield potential. In case of soybean, the demand, there is a consistent demand throughout the growing season. As you can see that by the R2 stage, it requires only it picks up only up to 30% of the K needs. And there is a more demand throughout the growing season. So that tells a little bit about the demand for the potassium throughout the growing season for corn versus the beans. Now I will share you two case studies. The first one will be on the corn nitrogen studies we have conducted in 2020, and another one on the soybean potassium. So let's take a look at the result from the corn nitrogen studies from 2020. So in this one, these are the results showing on the corn yield response to nitrogen rate in the dryland site. You can see that we were able to, these are the nitrogen rate going all the way from 0 pound nitrogen application to all the way to 150 pound nitrogen application. So this texture on this side was pure sand up to 3 or 4 feet deep. So it was difficult to grow crops, but that was the idea, that can we manage the yield potential through the nitrogen application. So here we are showing when we applied nitrogen application, as we increased, there was an increase in the yield, and the highest was still up to 45 pounds per acre. So we could not make maximum use of the nitrogen application in achieving higher yield. So in this chart, what I am showing is the use of the stabilizers. So several companies, they make the nitrogen stabilizers. So the goal of the stabilizer is to keep the nitrogen protected and make it available for longer period of time, so plants can use it more efficiently. So there are two goals. That the first, that we can either reduce the nitrogen required to achieve the maximum yield, or we can increase the yield with the use of the stabilizers. So we can see that the nitrogen stabilizer, they all have a different response, but we could not find the benefit of these stabilizers in improving the yield or decreasing the fertilizer application. As you can see that this is the yield achieved by 150 pound application. So none of them were able to surpass those yield levels. So this is the result from the corn yield response trial at the irrigated site. And as you can see that we were able to achieve 200 plus bushel yield at this site. And again, the response was quite clear. When we did not apply any nitrogen, the yield was around 75 bushels. And we were able to maximize it up to 210 or 220 bushel, whatever that number is. So the maximum rate required at this site was 250 pound. So I want to make a comment. We do want to, the recommendation for the corn is based on the yield goal at the dryland or irrigated side. So we do not have a yield goal based recommendation per se, but one goal that is quite common to use in most of the corn belt is 1.2 yield goal. So basically you're saying that for every 1 bushel of corn, you have to apply 1.2 pound of nitrogen. So if your yield goal is actually 200 bushel, you are supposed to have 240 pound of nitrogen application. So that falls around that area, 1.2 pound per bushel yield goal. So I can say that for the irrigated side, we were able to, we are within that objective or the goal of achieving 200 bushel. So now let's take a look on these stabilizers. So we tested similar stabilizer at this site also. And as you can see, none of them were able to level the yield that we achieved with the nitrogen application. So we can say that based on these two environments, that nitrogen stabilizers were ineffective. I cannot make a comment that it might not be effective in other environment, but since these are the limited environment we have tested, this is what I can comment about. And if you have any question about the stabilizer, feel free to call me or email me, and I can help you further to help you in making decision whether it is useful in your conditions or not. Now I'm going to switch my slides to the second case study, which is about soybean potassium. We have done these studies in 2017 and 18. My master degree student, it was her project. And I can show you here in this slide is on the x-axis is the potassium application rates. So we applied all the way from 0 to 200 pound K2O per acre. And on the y-axis, these are the yield. So the highest yield was achieved when we did not apply any potassium. And there was a linear decrease in the yield with the increase in the potassium application. So that is not something we do talk about quite often. However, there are several studies for several crops where we have seen this phenomena. And one of the reasons we have seen the yield decline, because we have seen in this study that we have done the soil testing just based on our current recommendation, which is 6 or 8 inch topsoil sampling. However, we do need to consider if there is any subsoil K reserve that can be used to maximize the yield. So that was the case, that we had more K sitting within 10 to 12 inches around the clay pan. That could be used for the soybean roots. And then why the decline happens, I can make a comment that the decline is just because soybean is more sensitive to any kind of salt than any other crop. So we do need to think about our notion that we put potassium chloride as a prerequisite to achieve higher yield. So potassium chloride is actually has a high salt index compared to potassium sulfate or Kmag. So I with this year we are going to do 5 on-farm trial to test it out. What happens when we apply more KCl? Can we see similar kind of trend? So if you are interested in some kind of research like that, I will be happy to talk to you. I also want to make a comment that what happens that we have seen 1 bushel yield decline with every 40 pound of K2O application. And it was similar in 2018 also. So we have seen that we have seen a 1 bushel decline with every 40 pound potassium application. So the difference in this 2018 and 2017 environment is 2017, the yield that it was a high yielding environment, while in 2018 the yield was around 35 bushels per acre. So based on these 2 case studies, I can say that you have, in order to make profitable corn and beans, you have to do periodic soil sampling, not only from the topsoil, but also from the subsoil, and especially to account for the nitrogen and potassium, which are the major input for corn, and potassium per se for the soybean. And in case if you do consider subsoil fertility, and you can do plant tissue sampling during the growing season as a diagnostic tool and correct any nutrient deficiency symptoms that you come across. So these are some quick thoughts I have in 10 minutes presentation, and I'll be happy to answer any question that you have. Thank you.